Today we're on page 4 of our Chapter 4 notes packet. Now if you need to, just flip back to page 3 and read over functions and the vertical line test. All right, remember from an equation, if there's a y in the equation and it's not squared, then the equation is an equation of a function. And if it's a graph and it passes the vertical line test, then the graph is a graph of a function. Now we can easily tell if a graph function is one-to-one by performing the horizontal line test. Remember the vertical line test, the BLT, to determine if a relation is a function. In order for a function to be one-to-one, it must also pass a horizontal line test. Which of the following is a one-to-one function? So we draw vertical lines to be a function, and that's okay. Now horizontal lines, we draw horizontal lines and see how our horizontal lines are hitting the graph at more than one point. So this is not one-to-one. Take our next graph, draw horizontal lines. Yes, each horizontal line hits the graph at only one point, so this is a one-to-one function. And our third, drawing horizontal lines. Each horizontal line hits the graph at only one point, so it is one-to-one. So now on your own, pause the video if you would, and try the next 5 questions on page 4 on your own. Okay. Is 2x squared equals 1 plus 5, y plus 5 a function? Well, there's a y. It's not squared, so yes it is. Number 2, is x squared plus y squared equals 16 a function? There's y, but it's squared, so no, it is not a function. And hopefully, if you recall from geometry last year, that this is actually the equation of a circle with center, the origin, and radius of 4. And a circle would not pass the vertical line test, nor would it pass the horizontal line test. But in order to be a function, it must pass, a graph must pass the vertical line test. Is every line a function? Almost every. No. Vertical lines are not functions. Right? If we had a vertical line, let's say this vertical line x equals 2, right? Does it pass the vertical line test? No, it fails miserably. Number 4, is the graph at the right the graph of a function? Does it pass the vertical line test? No. Fails the vertical line test. Number 5, is the graph at the right the graph of a function? Yes. Passes the vertical line test. Is it one-to-one? So if we draw horizontal lines, does it pass the horizontal line test? No. It's not one-to-one because it fails the horizontal line test. Next, page 5, the notation f of x is just another name for y. Although f is most frequently used letter for function notation, g and h are also commonly seen, and almost any other letter is possible. Now, instead of saying if y equals 3x squared minus 5x. What is y when x is equal to negative 2? We can say if f of x equals 3x squared minus 5, find f of negative 2. In other words, evaluate f of negative 2. In other words, evaluate. So what we would do in this case, we substitute each x with negative 2. Substitute negative 2 in for x. And we're just evaluating the right-hand side. We're just simplifying this. Negative 2 squared is 4, times 3 is 12, and 12 subtract 5 is 7. So f of negative 2 would equal 7. Some more examples. F of x equals negative 2x plus 4. Find f of 3. So we say f of 3 is equal to negative 2 times 3 plus 4. We're replacing our x's with 3. Negative 2 times 3 is negative 6, plus 4 is negative 2. B, find f of negative 1. F of negative 1 equals negative 1 squared minus 3 times negative 1 plus 4. And it's perfectly fine if you want to key this exactly as is into the calculator to evaluate. I'll continue by hand. Negative 1 squared is 1. The double negative here, negative 3 times negative 1 is going to be positive 3. Plus 4, 4 and 4 is 8. So why don't you try C on your own? Again, pause the video if you would. Alright, so f of 10 equals 40. Subtract 15, which is 25. Do 1 and 2. Pause the video, do 1 and 2 on your own. Find f of negative 3. So we're replacing our x's with negative 3. Evaluating the right-hand side. Negative 6 minus 5 is negative 11. F of 4. Negative 2 times 4 squared minus 4 plus 5. So 4 squared is 16 times negative 2 is negative 32. Minus 4 is negative 36 plus 5 should get us to negative 31. Now number 3. For the graph, find the following f of x values. So f of negative 3. So for an x value of negative 3, what is our y value on the graph? We would be right here. And what is our y value? 3. F of negative 4. Locate our x value of negative 4 on the graph. Here we are. Our y value is positive 4. F of 0. X value of 0. Here, y value positive 2. Pause the video, try D and E. F value of 1, x value of 1, y value of 2, and f of 5. Nothing. Not 0, nothing. Okay? We'll leave it blank. Doesn't exist. Just put none in parentheses. Is this a function? Does it pass the vertical line test? Does it pass the vertical line test? Yes. Is this one-to-one? Does it pass the horizontal line test? No. Remind me tomorrow to show you a way of evaluating the functions using the calculator. And this concludes our video for tonight.